Hi, if you take a look at what we covered today, then you'll notice that we don't actually have much. The first thing to do is a recapitulation of the important notions from the previous lecture. The second one is our main discussion, which will be about the traditional square of opposition, the nature of inference in general, and the process of induction. And lastly, I'll try to provide assignments for you to go over. From our previous lecture, we learned that propositions do have three important components, namely the subject, copula, and predicate, and that the subject and the predicate terms are representative of their respective classes, and that propositions have quantitative and qualitative aspects, so that we have a universal affirmative proposition, which is called a proposition, and an e proposition, which refers to universal negative, and I, which is known also as the particular affirmative proposition, and o, the particular negative statement or proposition. Now, propositions can be expressed in two ways. We can show them both in standard notation and formal equivalence. And in any case, they have to be distributed in terms of their terms component, because the distribution of terms in a proposition is important to efficiently plotting them in both Euler and Venn diagram. For today's class, we will talk about the nature of the traditional. Now, this is what it's like. You can see here a box, and we call this box the oppositional square. Now, it presents to us the relationship between and among propositions. So, what we can see here are four relationships. The first relationship, well, it depends actually on how you look at it, but the primary relationship in an oppositional square is one with or between proposition A and O and E and I. And we call this relationship the contradictory relation. The other kind of relationship here, or relation, is between A and E. This is what they call contrary relation. And there is another one that is structural, because it presents a relationship between the universal and the particular. That relationship is subaltern, and below we have this sub-contrary relation. Now let's see how this thing works. Perhaps we begin with the contradictory relation with all dogs are cats as our primary statement. Now, the relationship here is between directly opposite with value. It's with A and O and D and I. Now it says if A is true, then O is false, and yeah, the other way around, right? And if one is true, the other way is essentially false. So if one is false, the other one is essentially true. That's the contradictory relationship. Now, the contrary relationship is a bit technical, but not quite, because it says that at least one proposition is false and both cannot be true. So the opposition here is only partial. It's exclusive to A and E, and the other way around, vice versa. So it says that if A is true, then E is false, right? They can't be both true. Or when E is true, A is false. But there is also a complication when you say A is false, therefore what? A can be either true or false, and that's still okay because at least both cannot be true, right? And it's perfectly possible or okay if you still say that A is false, then A is false. This one is still perfect because at least one is false. Both can be false, but both cannot be true. That's the relationship between contrary statements. And what about the next ones? So the thing with subcontrary is that it's at least one is true and not both false. It's exclusive to I and O relationship. Now, if I is false, then O is true, right? Because they cannot be both false. Or O is false, I is true. But it begins with like false statement, right? So if I is true, and O is true, or O true and I true, then we still have here actually good relationship. This is not yet illicit because both of them can be true. But if I is false, then O is also false, and O is false, and the other one yields still to false proposition. Then we now have an illicit subcontrary. Now, the subaltern relationship is well easy to follow because it says truth flows downward and falsity goes upward or it flows upward. So that if A is true, then I is essentially true, right? And if or if A E rather is true, then O is true. So the universal flows downward. Like the truth of the universal um, affects the particular in the same way. And the problem is if the universal is F, we cannot conclude uh, immediately that um, the particular is also false because that is going to be an illicit subaltern. So if the but if the particular is false, then the universal follows, and it's going to be different if you start with true particulars and end with true universals. So that's how the relationship here works. Now, let us try to apply this um, to several propositional structures or problems. Well, let's take a look at these examples. We've got an A proposition which is true, and an A proposition becomes false because the relationship is contrary. If one is true, the other is false. They can't be both true at the same time. And the I proposition is true because the truth of the universal flows downward, right? And the O proposition here is the contradictory of A, that is why it's F. And you can have the same analysis here, but the peculiar thing here is, or one note of worthy of note is the relationship between A and I. If we start with an FA, then we'll get an illicit subaltern I. Why? Because um, we don't know yet if this is um, what if we can't have it both. We can't have it either true or false because if we get an I here, an I proposition, an I subaltern, then the relationship still remains illicit because the falsity of the A doesn't flow downward and does not affect I in the same way. And if it's false, or if it's either true or false, they the relationship remains illicit, right? Um, and this one becomes T because this is contradictory relationship. Now, the same case with I, that is T, in relation to what? This is not I, this is O. In relation to E, um, E here is illicit because either true or false. The principle is that we don't begin with true particular and affect the universal upwardly. We always begin with false particular and affect the universal the same way, right? So that's the idea of illicit relationship. Okay. Um, if we check the formal correctness of this each of these combinations, then we'll get the next example. Now, another way of looking at it is to draw the formal correctness of each of these combinations. When you say, for example, that I is true, if I is true, then O is false, then you'll get a valid combination because, again, the principle that works with I and O relationship, the sub-contrary relationship, says that both cannot be false. At least one is true, right? And with in relation to A, then we'll get here an invalid combination or opposition because we don't start with true particular. So that this one is actually illicit subaltern, right? And every illicit relationship or combination is invalid. So if I is true, then A is true. Well, it would have been correct if we start with A to be true, then affects I downwardly, but this one remains invalid because it's illicit relationship. And then we get E T in relation to I T, or I T then E T, and still we get an invalid relationship. Excuse me. But we've got a true I here and a false E. That's contradictory. And that was all about the square of opposition. Now we move on to the next part of the chapter, which is actually going back to chapter 4.4, which is about inferences and deduction operations with conversion, obversion, and contraposition. Now, an inference, time and again, is a conclusion reached on the basis of evidence and reasoning. We already had a discussion on this, and we are no longer going back to it. But here's another concept which is new under this induction. Um, we have three processes here: conversion, obversion, and contraposition. Now, induction processes are operations that can be performed on a categorical proposition. That's one thing to consider. And they will result in a new statement that may or may not have the same meaning and truth value as the original statement. So it's going to be a reformulation of the given, right? Now the result may be totally new or only partly new. Now let's see how it happens. Let's have conversion as our first operation. It is done through switching terms. Well, that means that we switch or swap the predicate term with the predicate term. Did I say predicate term with the predicate term? Swap subject predicate. Okay, maybe that's the proper way of putting it. So from S is P or SRP to PS. So there's an inversion, right? Now, with this kind of inversion, it is stated that only propositions E and I will show logically equivalent statements because they share the same truth value. And let's see how it works and what's the meaning of it. Now, to show what that means, we'll get the proof A, which will lead us back to the distribution of terms. Let's have the terms here all lined up vertically. And we'll start with all S are P, which is a proposition, and whose distribution looks very much like this. If you convert that, then you'll get all P are S, but the distribution of terms um, is already altered. So from SU to SP, then P to PU, right? So there's a change there. They no longer have the same truth value and distribution. But with E rather, not A, you'll get the same distribution here, right? From PU to PU and SU. Also with I, because there's no change in the truth value and distribution of terms, or yeah, at all, even if the, the terms in the proposition are switched or interchanged. Um, However, with O, well, you can very clearly see that there is a change there. Now, the other way is to show them in Venn diagram. Let's see. I think it's clearer here now with Venn diagram. Look at this. Um, if you look at the relationship between the given propositions and their converse, that is the outcome or the byproduct of the process we just did. Then you'll get, again, very clearly here, only E, this, and I proposition to be containing the same truth value and um, form. In other words, they are logically equivalent, right? There is no change at all. And I think if my memory serves me right, I already discussed how this relationship in Venn diagram works, and yeah, maybe if you have questions, then just open them up later in the next meeting. But for now, let's proceed with the next deduction process. Now, the second process is called obversion. Now, you do this by negating quality and by class complementing the predicate term. What um, these instructions mean will be shown by first, again, aligning or lining up them in a vertical way and try to show how the changes look. So we get first the A proposition, all SRP standard proposition, and then the the obverse, which says no S or none P. So the first thing we did was we negate equality. Now the quality is A, affirmative. Here it becomes negative, from affirmative to negative. If you negate the quality of A, then you'll get E, right? And but you know the quantity remains, right? So this is universal affirmative. The negation equivalent, the opposite of that is universal negative. So you just negate the quality without touching the quantity. But then you class complement the predicate term. So from P to non-P. So we'll get this, no S or non-P. Again, you negate the quality, which is affirmative in the original, and you class complement the non-P. A complement, by the way, is an expression of, in logic, especially here, in Venn diagram later, it refers to the class outside of this class or to the non-member of this class, right? Of particular P. So non-P means not members of P. And then the same thing holds for the rest of the um, propositions here. You only need to, well, negate the quality. If it's negative, make it positive without changing the quantity. If it's positive, then do make it otherwise. And complement the predicate term. Now, in Venn diagram, this is more lucid. Now, look at the Venn diagram for obversion. It shows rather that every proposition here contains logical equivalence with the given, right? Or the given formulation or the given form is logically equivalent with the obverse, with the byproduct of the abduction operation. Look at that. When you say all A are B, then you actually say it in another form with no A or none B, right? So if um, dogs exist, they belong to the um, class of cats, so that no dogs can exist outside the non-cats class, right? That's how we explain that. And if you say no A or B, therefore all A are non-B. So this is how it looks. They are all equivalent, um, perfectly the same, right? Their logical status is that they are the same, identical, although they are expressed in obverse forms. Now, let's see if the same thing is true with contraposition. Now, look at this. You do the contraposition process by switching terms, like what we did with conversion, and class complement both terms. So you complement your class complement S and class complement B. Not only that, you will be switching them, you interchange them. So this is how we do it. Start again with all SRP with the distribution, and then switch the terms. We say all non-P or non-S because we have to complement both terms. So it changes the distribution of terms here. Look at that below here. They change, right? And no S or P, therefore no non-P or non-S. And the distribution of terms, time and again, change. And then some S or P, some non-P or non-S, then, oh, we have here, wow, the same distribution. And let's see in the Venn diagram later how it looks. And then we have, yeah. So it's only the I preposition that gets the the same identical or logical equivalence, right? Now let's see in Venn diagram what these things are like. Oh, actually, this is surprising. Hmm. So we've only have one relationship here, like combination that um, shows logical equivalence, and that is between this given proposition all A are B and all non-B are non-A. Yeah, so the statements are actually not totally altered, but they show a particular region. Um, well, they show most of them show different regions in the Venn diagram, and it's really interesting. All right, so this way it works. Like when you say all A are B, then you say all non-B are non-A, right? All non-B, all non-B. What is non-B here? Yes, this is the non-B part, right? Are non-A, because if A exists, then that A should be part of B, right? Or should be accommodated by the B class. Or that no, that all non-cats are non-A's, non-dogs. All non-cats are non-dogs. So these are the non-cats members, and they are non-dogs members also. Because if dogs exist, they should belong, they belong to the class of cats, right? That's how it works. But this one is, well, how do you explain this? No A or B, no non-B. These are regions outside the circles, right? Outside the circles. No non-B, R non-A. They refer to the external limits, or to the external, or to the limits of the classes here in the the Venn diagram, but they don't refer to the, they can only refer to the diagram, to the circles, indirectly. So it says that um, the non-B's that exist are what? They refer to the non-B's are at the same time non-A's, right? So these are these are it. But if you notice, there are the non-B does not exist here inside the circle because this is the B class, right? So nothing can actually be accommodated both in these circles. And that's why the non-B's and non-A's are here, right? They are outside the circle. But then there are non-B's that are A's, right? And what happened to them? This non-B here, which is A non-B, exists. And there are members. In fact, there is a universal membership here. And there are also A's that are B's. And they still have a universal membership here. It's not being shaded or whatever. So the point here is that they refer back to the relationship between A and B indirectly, right? So this is how it's shown. Okay, so this is it. There is at least one member of non-B that are not part of non-A, right? So a non-B that is non-A here, okay? Or it can also exist somewhere else, but it's close. It must be placed close to the class of B. And then same thing here goes with what? The O proposition. It says some A are not B. And we have here the same identical propositions as well, right? Some non-B are not non-A. Huh. Well, yeah, non-B are not non-A, right? Double negation here. It means that some non-B are A. That's what it means. Some A are not B. Okay, that's the same. So, in contraposition, we have two identical um, formula or statements. We have identical outcomes or an outcome with proposition A and proposition O. And yeah, and that's how it goes. And it's interesting how they show some possibility of what of the principle of identity in Venn diagram, right? Hmm, interesting. I find it really interesting. Anyway, so what's next? Well, perhaps the question that now should preoccupy us is whether we can really make use of them or if they really matter, and if they do, why do they matter, right? And how do they matter? That's the next question to raise. And can we set up oppositional relations for these operations? I think we can. Yes, we can. We just follow the there's a there's a there's actually what there's a hint, and the hint is found in the logical um, relationship between given proposition and the obverse, and given proposition and the converse and contrapositive. So if you notice, um, in obversion, if you can still remember, in obversion, oh sorry, in conversion, only E and I propositions have the same or have the same truth value, right? So if an A proposition given proposition is true, then its converse is also true. Sorry, E proposition is true, then the converse is also true. And if I proposition is given or given true, then its converse is also true. But for obversion, because they are all identical or similar, then you can get the same truth value or truth claim. So if an A is proposition is true, then its obverse is necessarily true as well. So the same principle applies um, with the rest of the propositions for obversion. But in contraposition, you can only get to the same propositions or identical propositions, right? Remember, you only have A and O. So A proposition is true, then its contrapositive is true. And if O is true, then the contrapositive is true. If it's false, then it's false, right? So that's how you set the uh, oppositional relations or relations of truth value for the whole induction, obversion, and contraposition processes. And well, in the end, if we really are serious with the question, how do they matter and what do they matter? Why do they matter? Then we only have to think that these are propositions and that propositions are building blocks or let's just say fundamental to the reasoning structure itself. So they will eventually matter. I mean, if you now jump to the consideration of arguments and syllogism and many others. So their importance may not be yet felt, but eventually, as we go along, you can see how they really work, and they work in a nasty, sometimes really nasty, but in in powerful ways. And yeah, that's it. So I hope you guys learned something from the discussion, and um, stay safe. Keep posted. Thank you.